Okay, this is question 16. It's just a problem-solving question. So students given following information regarding 3 half equations and 3 numerical values of the standard electrode potential, which are correct but incorrectly assigned to the 3 half equations. Now, this doesn't actually correlate to the standard electrode potentials you'd find on the electrochemical series, but instead, you're just meant to be able to look at the observations in this question and then work out one of the standard electrode potential values. So, student constructs half cells, measures them against the standard hydrogen half cell, which everything is measured against in the electrochemical series. And the following observations were made either during or after electrochemical cell discharge electricity for several minutes, and the above information can only be used to find one of the standard electrode potential values to its corresponding half equation. So identify this half equation by placing the correct standard electrode potential value next to its corresponding half equation in the table below. And that's what the question is asking you to do for this first bit. So, for this one, electron flow was detected passing from the standard hydrogen half cell to the half cell containing the silver electrode. Okay, so electron flow goes from the anode to the cathode. So we know we were experiencing reduction in our silver half cell. And we know reduction happens with the stronger oxidant. So higher up on the electrochemical series. Here, the mass of the cadmium electrode decreased. So, if we saw, again, it's showing us a reduction equation here. If this reduction equation was proceeding this way, then we would actually expect the cadmium electrode, the mass, to increase, because we've got cadmium ions gaining electrons, plating onto our cadmium electrode, mass would increase, which indicates actually the reaction is going the other way, and it's oxidation, which means this reaction would actually fall below the hydrogen half cell on the electrochemical series, on the one we're constructing. So, as we know, the further you go up the electrochemical series, the more positive our standard electrode potentials are. So, this is going to be more negative. 2 is going to be more negative than 1. Here, we have lead sulfate. Plus 2 electrons is lead solid plus sulfate ions. The pH of the solution in the standard half cell increased. So, what goes on in our standard hydrogen half cell? We have it about the middle point of electrochemical series, just a little bit lower. We can see what happens in our standard hydrogen half cell. We have 2 hydrogens plus 2 electrons producing hydrogen gas. If the pH in the solution increased, just clicked on something there, increased, that means the pH went up, that means it became more basic. Therefore, we know that we've been removing hydrogens from that situation. Therefore, we know that the half cell reaction for the hydrogen half cell was going in a forward direction, which means, and that was undergoing reduction, which means this reaction was going in not negative direction, in reverse direction. It must have been undergoing oxidation. That suggests that, again, for oxidation to be happening, it must mean that this falls lower in the electrochemical series than our hydrogen half cell. Therefore, the only one we can absolutely assign, because it must fall above the hydrogen half cell, is 1. And because it gets more positive the higher up you go, this must be our, is it plus 0.22? Plus 0.2. Excuse my terrible 2's. There we go. That's question 16, part A.